Okay, so we're going to look at the last couple of options here when dealing with limits of functions. Here it says solving limits of functions by substitution. Of course, we've done some substitution already where just sort of on a regular function, a continuous function, where subbing in the value of x that we're approaching actually gives us a solution right away. That's not what's going to happen here. So although it's a fairly messy one, it will work fine for us. If we do substitute this value in for x, what we get on top is -2 plus 2, so 0. And in the denominator here, we put the -16,384 in. We get positive 16 minus 16 is 0. So again, we're getting the undefined 0 divided by 0 situation. And so we need to come up with a better way to solve this. Straight substitution doesn't work. Now normally if I saw some sort of a polynomial function over a polynomial, I'd look to factor. But obviously, again, looking at this, factoring doesn't seem like a too simple a solution for us. So what we'll do is use a different form of substitution. Essentially, I can sort of look at this and see that 1/14, denominator 14, 2/7, denominator 14 would be a possibility. 2 and 16, there seems to be some relation between the values in the numerator and the values in the denominator. So what I'm going to substitute is the letter u for the value x to the 1/14. And you'll see sort of what happens. I'm going to let u equal x to the 1/14. Hopefully that's visible for you. Then u squared is x to the 2/14, which is x to the 1/7, and u to the 4th is x to the 4/14, or x to the 2/7. And so we are now able to represent this term and this term as u and u to the 4th. And it's going to make for a much nicer looking equation than the one that we were dealing with initially. This looks like a question I should be able to solve. Now the second part here though is I had x approaching -16,384. Obviously I can't have that here if I'm going to be dealing with expressions in terms of u. And so we have to determine how we're going to represent that instead. And so if u is x to the 1/14 and x is -16,384, then u is that same value to the 1/14. Okay, so it says right here u is equal to x, whatever x is, to the 1/14. Obviously, if that's the value here, then plugging that into the calculator, we'll find that u has to be -2. So u being -2 is the equivalent expression here to what we had up top. And now this one we should be able to solve normally. I see in my denominator u to the 4th minus 16. That's a difference of squares. And so I'm going to end up with u squared minus 4 times u squared plus 4. And if I continue that further, I see I have another difference of squares here, which will be u plus 2, u minus 2, and then still u squared plus 4. And of course, u plus 2 in the numerator will divide out u plus 2 in the denominator. And at that point, I should be able to make my substitution of -2 and solve for the final answer. Last possibility here, or last one that we'll be seeing, evaluating a limit that involves an absolute value. And basically, to do this, we need to evaluate from, sort of around the key point here and determine where we have a positive, or where the absolute value originally was positive and where it was originally negative, and adjust accordingly. So in this case, x minus 2 has to be a positive value at the end. That's what the absolute value means. If x is a value greater than 2 to start, sort of here, then the numerator would have been, or what's inside the absolute value would have been positive already, And of course, there's no change to the expression. So this expression represents this expression as long as x is greater than 2. For values where the absolute value is negative, so values like +1, 0, anytime x is less than 2, this term inside the absolute value is negative. And so in order to change that value to be a positive value, we have to multiply it by -1. Okay, so it's a little strange, obviously, but if you put the value 0 in here, we get 0 minus 2 times -1 is +2. -5 would be -5 minus 2 is -7 times -1 is +7. So putting the negative sign in is required to indicate that we're changing what was in here to guarantee that it's going to be positive moving forward. And then of course, once we've done that, this expression can be looked at to determine what's happening on as we come from the right side for our limit. This can be used to determine what happens as we come from the left side, and either we can find the overall limit or simply the left and right limits. So here from the right hand side the limit is +1, from the left hand side the limit is -1, and so the overall limit is undefined. And it says illustrate with a graph. My suggestion is you go into Desmos, and this is how we do absolute value. Just ABS around the expression, and you can see here this is the left side as I'm approaching my value here. I've got -1. As I'm approaching from the right side, I've got a limit of +1. Again, overall, the limit does not exist.